Sometimes it will be necessary to approximate the mean for a data set that has already been organized into a grouped frequency distribution. The steps are that we would make a table that has some columns. The first one would contain the classes. The second one would contain the frequencies of those classes. The third one would have the midpoints of those classes. And then the fourth one would have the products of the frequencies and the midpoints. So the steps then are to find the midpoints of each class and place them in column C, multiply the frequency by the midpoint for each class, and place the product in column D. Then find the sum for column D and divide the sum obtained in column D by the sum of the frequencies obtained in column B. So if we think about this, what we're really doing then is we're using the midpoints as an estimate for each of the data values in the data set. And then when we multiply that by the frequencies, then we have an estimate of what the total value in each class would be for the data values. And then when we find the sum of the frequencies, we're actually finding n, the size of the data set. So here we have a grouped frequency distribution. We have the classes over here, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and 25 to 29. We have the frequencies for these classes, 5, 8, 13, 9, and 5. So in other words, there are 5 data values between the values of 5 and 9. There are 8 data values between the values of 10 and 14, 13 data values between the values of 15 and 19, 9 data values from 20 to 24, and 5 data values from 25 to 29. So the first thing then that we need to do is find the midpoint for each of these classes. We're going to wind up with a midpoint of 7 for the first class, 12 for the second class, 17, 22, and 27. And we see that these midpoints differ by 5, which they should, as the class limits also differ by 5. Now we'll need to find the products of the frequencies and the midpoints. And we'll do that by multiplying then the frequencies and the midpoints that we already have in the table. So we would have 35, 96, 221, 198, and 135. Now we would find these sums. The sum of the frequencies, that'll actually give us the size of the data set. The number of data values in each class, then added up, would give us how many values there are in the data set. That sum is 40 when we add 5, 8, 13, 9, and 5. The products of the frequencies and the midpoints, 35, 96, 221, 198, and 135 added together, will give us 685. So our estimate of the mean then we will find by using this formula, x bar equal to the sum of the products of the frequencies and the midpoints divided by the size of the data set. So we would have 685 divided by 40, which would give us 17.125. Now we need to round this according to the rounding rule for the mean. We see from our class limits that the measurement precision for the individual data values would have been whole numbers. We also see that in the class width, that it's 5. The mean then should be rounded to one more decimal place than occurs in the raw data, so in other words, the tenths place. So here is our estimate then for the mean for the data set that would have been used to construct this grouped frequency distribution.